Good students, so on this clip, we're going to be going over 3 examples on how to use right triangle trig to find missing parts of a right triangle, okay? So let's write down the instruction for the problems. So there to find the value of the indicated variables in the given right triangles, the given right triangles, okay? All right, so let's take a look at the first one. So question number 1, we have a right triangle of the following orientation. Let's go ahead and sketch it first. All right, so there you have the right triangle. Obviously, this is the right angle right here. That's a 90-degree angle. Up there, and this is 33 degrees. This side is negative 5 units long, and this is x. So in this case, we're going to be looking for the variable, which is x. All right, so how do we know which trig ratio we need to use since we're dealing with angles and sides? So what we'll do is we'll write a formula, SOHCAHTOA. So we're either going to be using sine, cosine, or tangent. All right, so how do we know which one to use? To determine the right choice, we just go with the label. Okay, so let's look at the triangle. This is the angle right here that makes this side right here the opposite. Okay, the side opposite the reference angle is always the opposite. The side opposite the 90-degree angle is always the hypotenuse because it's always the longest side. Okay, opposite hypotenuse, and this other side right here is the adjacent. Okay, if you look at this problem, I don't know the adjacent and I don't need the adjacent, so I'm going to scrap the adjacent. Okay, it doesn't play any role in this problem, so let's eliminate that. So we're looking at O and H, so we're going to ask ourselves a question. Which trig ratio has O and H in it? Sine, cosine, or tangent? OH is so we're going to be using sine. Okay, so sine, theta in this case, the reference angle is 33 degrees, sine 33, is equal to opposite, which is 5 over hypotenuse, which is x. All right. So we need to get x by itself. So we have x downstairs here, so that's a problem. We need to bring it up first. So to bring x up, we need to multiply both sides by x. So what we're going to have is x sine 33 equals 5. All right. Now what we're going to do next is get x by itself by dividing both sides by sine 33. So we'll divide this side by sine 33 and this side by sine 33. All right, and that gives us x equals 5 over sine 33. Okay, so this is the exact answer. What we're going to do now is plug this into a calculator to see what we'll get. All right, so in this problem, we're dealing with degrees, so we have to be careful. Let me indicate that here. We have degrees, so degree, and those are degrees. So we're dealing with degrees. So when we're entering our angular value into a calculator, we have to make sure that it's a degree. So we're going to check that first, press and make sure degree is highlighted. So scroll down to the third row, scroll over to degree, press enter, and then now we're in degree mode. So what we're going to do is compute 5 divided by sine 33, and the answer is 9.18. Okay, so x is approximately, change my color, x is approximately 9.18. Okay, x is approximately 9.18, and we can put it in our triangle. All right, so there you have it. All right, let's move on to question number 2. Similar problem. Number 2, we have the right triangle with the following orientation. Let's go ahead and sketch it. Um, so we have, this is the reference angle. In this case, we do not know what it is. It's x degrees. This is 2 right here. This is 5, and this is your right angle. Okay. So how do we find x? So since it involves size of a triangle and an angle, we need to use right triangle trig. So Katoa, one of these choices will apply to this problem. Okay. Is it sine, cosine, or tangent? That's the question. By labeling our triangles and isolating what we need and what we know, we can determine which trig ratio to use. Okay, so let's label our triangle. This is the angle, so the side opposite the reference angle was always the opposite. Okay, the longest side is the hypotenuse. I know that this is the longest side because it is opposite to 90 degrees, and the other side is the adjacent. So the question is, which one do we not need or know? See, opposite, we don't know it, we don't need it, so we scratch it. The only two players here, the only two players that count here is adjacent and hypotenuse. So which one has only adjacent and hypotenuse in it? It's cosine, right? Because of cos. So cosine is a trig ratio that we're going to use to solve for x. All right. So let's set up the trig ratio. Cosine of the angle, in this case, the angle is x degrees. Cosine of x equals adjacent, which is 2, over hypotenuse, which is 5. Now, how do you get rid of cosine? We never divide by cosine. That's a common mistake most people make. You cannot divide by cosine. If you want to undo cosine, you have to use its inverse, known as the arc cos or the inverse cosine. Okay, so we're going to take the inverse cosine of both sides. So the inverse cosine of the left side is the inverse cosine of cosine x. And on the right side, you take the inverse cosine of 2 over 5. Okay. On the left side, inverse cosine and cosine cancel each other out. So we're going to have x equals the inverse cosine of 2 over 5. All right. Now what we're going to do is find the calculator approximation of what this angular measure is. So let's go back to the calculator. So we're going to do second function cosine will take us to the inverse cosine of 2 divided by 5. And the answer is 66.42 to the 100th place. Okay, so it's approximately 66.42 degrees. All right. All right, so let's go ahead and include that measure in our triangle. So this angle right here that we do not know, this one is 66.42. Put that in. This is 66.42. Okay. All right. Now let's go ahead and take a look at the last problem, question number 3. Question 3. We have a right triangle of this orientation. Go ahead and sketch that. This is the right angle right here, the 90-degree angle. We have the angle right here, 23. And this side right here measures y, and this side right here has a measure of 4. Okay, so in this case, we're looking for y. All right, so what trig ratio do we use here? So we're going to write down SOHCAHTOA and see which trig ratio is appropriate here. Okay. All right, so if we label the triangle, we can determine which one to use. So let's go ahead and label. This is the reference angle. That means the side opposite reference angle. This is the opposite. Okay. And then this side right here is the adjacent. The side opposite the longest side, namely the 90-degree angle, is the hypotenuse. So in this case, I do not know the hypotenuse. I don't need it, so I scratch it. The players here are just the adjacent and the opposite. So what trig ratio has opposite and adjacent in it? Is tan, right, for TOA. So that's what we're going to use in this problem. So tan of the angle is 23 degrees. Tan of 23 equals opposite, which is y over adjacent of 4. Okay? So to get y by itself, multiply both sides by 4. 4 is divide out, and we end up with y equals 4 tan 32, tan 23. Okay? So we're going to plug it in a calculator, and let's see what we get. So plug it in a calculator, we have 4, 10, 23. Final answer is 1.7 to the 100th place. So let's put that there, 1.7. So that's what the measure of, y is, 1.7. Okay, so there you have it. Thanks so much for taking the time to watch this video, and feel free to subscribe to my channel just by clicking up here. More videos can be found on mycoachchef.com. Thanks again, and have a wonderful day.